Hello, everyone. My name is John, and I'm joined with Paxton and Christian. And our senior design project was to research, design, and model a drivetrain capable of delivering power to all four wheels for the Society of Automotive Engineering Baja competition. And our project advisor was Samuel Wright. Our project was divided up into two phases. During the fall semester, we researched feasible options, and in the spring, we designed and modeled our selection. The research phase began by reviewing a wide variety of drivetrains, starting with the components that make up a drivetrain, and then looking into complete drivetrains and how all the components work together. Some of the criteria used when selecting the correct drivetrain were our budget, the weight of the drivetrain, the reliability of parts, and the availability of parts.
When we were looking at these criteria, we found the Grizzly 660 differentials, and these met the criteria we needed, so we started our design phase. These differentials are limited slip, so the wheels can rotate at slightly different speeds, allowing for a smaller turning radius, but it also will lock after one wheel slips a full rotation, sending power to both wheels on that axle. So we chose this for the front and rear differentials. Then we found a Peerless 700 series transmission that we noticed we probably could reorient some and use as a transfer case to send power to the rear and front. All of these parts were made for vehicles running well over 10 horsepower. So we know that with the SAE mandation of a 10 horsepower Briggs & Stratton engine on every vehicle, that these parts can withstand the forces we'll be putting into them. With this Peerless 700 transmission being a 5-speed transmission, gear ratios with that in series with the differentials is a much larger range of ratios than we have right now, which will be very beneficial for the team in the upcoming years.
While designing the drivetrain, we ran into the problem of the previous suspension that was on the vehicle. Therefore, we designed some A-arms to withstand the new forces that come along with the drive shaft being included with the differentials. We ended up using Lotus as well as SolidWorks to perform the FEA analysis on this, and we chose a 1,700-pound force to be used as a static loading on the A-arms. The result was that the yield strength was much higher than the force applied, so it should be able to withstand any forces that are performed during competition. We then performed some impulse calculations afterwards to validate these findings. Thank you.